Hi, we are live. We are live on YouTube. My name is Matt Kurantovic. Let's get started. Today, I will show you how to use Factory IO and TIA portal from Siemens to program a simple program um, with cylinder, pneumatic cylinder, like here on the screen, you see. We have the cylinder, we have simple control cabinet with a start button, the stop button, and boxes. Our task is to create a program in graphical language ladder logic diagram. And here you have the sample network for the ladder. On the left side, I have environment for programming. This is TIA portal. And on the right, I have Factory IO. Let's get started. You have the chat. For you, you can write a question. I will try to answer all the questions on the chat live. Okay. Firstly, I will go to the Factory IO and I will stop the system. And here I will show you how to use such a software. If you are new in industrial automation, um, you can start simulate industrial automation objects in digital twin. On the market, you can find a lot of such a software like Machine Simulator. This is our partner. Here I have Factory IO. And you can build such lines from ready-made elements from the library. Here we can drag and drop a conveyor, the table, the tables. Yeah. What's more, we have even gates, safety gates. We have manipulators like here. And also we can use ready-made scenes to simulate your industrial automation object. If you go to file and go here and go to scenes, you can choose one of those scenes like automated warehouse, manipulator, filling tank, and many more. But today we have prepared for you in our company Control Byte such a simple line with the main conveyor. This is the main conveyor, and another conveyor. Our task is to push packages to this conveyor and remove that from the line. Right on the chat, do you hear me? Do you see me? Right now I have the full screen. And maybe let's get started from the beginning. Here I have the simulator of the packages, and I can configure that. And the packages appears on the line on the conveyor. Next, I have the control cabinet. Here I can put some switches, like here I have the stop button. The stop button is green, and here I have the start button is green and the stop button is red. I can drag it, I can change the position of the stop button and the stop, and I can also add, if I want to, for example, emergency switch here. Yeah. And I can add to my configuration. Look at that. Here I have emergency stop. I can add it to my control cabinet. But for today's simple application, I will use only 2 buttons. Then we have the pusher. It could be pneumatic cylinder. Maybe if I go to my video library on the channel, on our YouTube channel, you can find the video, the newest video on programming pneumatic cylinders in the factory. Here we have the sample. And Jacob will show you how to program such a application with 2 pneumatic cylinders. Look at that. We have valves and we have cylinders. On such valves, you can find sensors, the position sensors. And yeah, we have 3.5 valve. We can manually control that, or we can use the PLC to control such a pneumatic cylinder. Usually in industrial automation, we use PLC to control such cylinders, and we use IOs, so input and outputs. To the inputs of the PLC, we can connect buttons like start button or stop button, and also sensors. Here for our application, we use back sensor and forward sensor. So back position and forward position of the sensor, of the pneumatic cylinder. So the full video you'll find on our channel. Let's go back to our factory IO application. And look at that, this cylinder has back limit. This is one of the sensor, the back limit sensor and front limit sensor. Thanks to that, we can see in our PLC, we can send such a signal to the PLC that the cylinder is in a back position or front position. If we go to the file and to drivers, here we have driver that communicate our virtual factory with PLC. And on the left, we have input signals from the start button, stop button. And look at that, we have 2 positions for our pneumatic cylinder, back limit and front limit. In the middle, we have also diffuse sensor. What is that? This is the sensor which detects the package on the line. Let's simulate that. Look at that. If we go to the beam of the sensor, it is energized. Okay, we can go to dock all tags and yeah, look at the front. Look at the diffuse sensor. If the package reaches the beam of the sensor, it energizes. Okay, I made a collision, but look at that. My application works very well if I start it. But it is programmed well. So here the package appear in the entry of the conveyor, then goes to on the main line. When diffuse sensor detects the package, the pusher, our pneumatic cylinder, starts and push the package to the remover. Of course, remember that our cylinder in this application should work from the back limit to the front limit. So we need to our cylinder need to go back to the back limit and then push the package. So those signals we send to the PLC inputs. If we go to the driver, here we have outputs of our PLC, and we have the pusher. So we start the job of our cylinder. So we push the package when we give the signal to this pusher, and we have two signals for two conveyors. One belt conveyor. This is the main conveyor, and another conveyor. Okay, now we know what input signals we can use in our application and what output signals. So we need to go to the TIA portal and we can start programming. But before that, I will show you how to use the basic instruction in PLC programming, which is, you can write in the chat, what is the basic instruction for ladder logic. Here I have a presentation, and look at that. What you need to do first, what do you need to learn first if you want to be a PLC programmer? Firstly, you need to master basic instructions for PLC for ladder logic. The first instruction is normally open contact. And the coil. Normally open contact, this is the symbol for the input of our PLC. And the coil, it could be the output of the PLC. If you want to program such a virtual factory, you need to install three simulators. First one is PLC simulator, and the next one is Factory IO, which is free for 14 days or for 30 days. 30 days, yeah. All the simulators are free to download. You can install that on the computer and you can start learning. You can write the first program after that, and then you need to master the standard library where you will find timers, counters, flip-flops, and triggers to detect signals, for example, from sensors. Let's go to the basic theory. The basic instruction is normally open contact. Here we have the symbol of such a contact, two lines in a network. Then we need to add the name of the variable with the prefix. If this variable is Boolean variable, we need to add prefix x, and this is the symbol for Boolean variables. Then we add the name of the variable. Also, in Siemens PLC, we add the address for inputs. Here we have the address for the first input. And then, if we know the basic instruction, we can create logical operations. Yeah, when we give the signal, for example, the start button is pressed, maybe I will show that on my screen. Yeah, look at that. Here we have the start button, normally open contact. When I press the start button, it changed the state from 0 to 1. Now, when the state of the button is 0, it is not pressed. Here we have we highlighted this button in blue. When I press the start button, it changes the color from blue to green. It means that the button is pressed. So, for such a normally open contact, we can define two states 0 and 1. 0 when the button is not pressed, 1 when the button is pressed. One value is a true value, false is zero value. When we know how to use normally open contact, we can go to create logical operations and operation. And here we have two buttons in series. We can create a truth table for that. When two buttons are not pressed, then we have the output. This is the false value. And only in one state, when two buttons are pressed, so they are in high states, then the output of such a logic gate is true. Another operation, basic operation, is logical operation OR. And here we have two buttons in parallel. Here, when two buttons are not pressed, we have the output 0, false. In other cases, the output is true. Another basic operation is normally closed contact. Opposite to normally open contact, we have normally closed contact. When, what does it mean? It means that when the button is not pressed, we have the true value here. And of course, we can create another logic gates like not or and not and. Okay, so how to create a program in ladder logic? Maybe I will turn off the monitoring in my PLC. And if you install such a software, you will get access to the simulator, and also you can create logic using instructions. Here you have instructions on the right. If you use ladder logic, this language, graphical language, you have basic instructions here. You have general folder, bit logic instructions. Like, look at that. You have normally open contact, normally closed, as I said, and the coil output. If you drag and drop, you can add such a instruction to your program. You can also add normally closed contact. If you know that, you can create the first network for your program. And here in this network, I added the start button, the stop button, and on the output, I added auxiliary variable, which is X state start. This variable indicates if our machine is in a start or stop state. And the first network in this program is a really popular program. This is a latching circuit. What does it mean? It means that this circuit remembers the state of our machine. When I press the start button, this variable remembers that the machine is in a start state, and we can start our process, our machine. And what's more, we have here the stop button. When we press the start button, the stop button, machine stops. Let's go to the next network, and here maybe I will turn on the monitoring once again, and I will explain that on our real machine. Okay, let's why I can see the monitoring. Wait a minute. Oh, look at that. Here I have the instance of my PLC simulator, but it's not the most important. Um, what we have here, we have the next network. When we are in a start state, our machine is in a start state. Then in a second network, we start the conveyor number 0 and conveyor number 1. We have two outputs and we start the conveyor. We also have the black for communication, our simulator with factor IO. Here we have that black. I will go offline once again and go online. And I will download the program once again to the PLC. Here you can compile such a program and you can load it to the PLC. And as you can see now, I can see the states. Okay, when I press the start button, look at that. All is highlighted in blue. It means that we are not in a start state. Machine is in a stop state. And also conveyors right now are not working. When we once again start the machine by pressing the start button, conveyor are in true state and they works. And the most important part of our program is network 3. Here we have more sophisticated instructions from extended library, standard library. Here we have the timer and SR flip-flop. In our course, on our platform, you'll find all in the presentation. And right now I will quickly present you the basic instructions that you can use in your project. Here we have T on timer. T on timer, and we have T off timer on this screen. This is timer on delay. When we press, for example, the start button, we count the time, and after the preset time, the output of this timer is on. When we release the push button, the output immediately goes to the low state. We have also timer off. This is the symbol of such a timer. Look at that. We have the input. Here we can connect a button to this timer. We have also preset time input, and we add here the value in time. For example, t hash 5s. This is 5 seconds for our block. And we have two outputs. The first output is Q output. After the center time, we this output is enabled, is set on, and also we have elapsed time output. Here we have the diagram, and in TIA portal we have also TONR timer. This is timer on delay, but also with reset input. Thanks to that, we can reset accumulated time value. Next, we have such instructions like counter up. We can count packages. This is the diagram of a counter up. Next, we have counter down. This is the symbol of that. We have CD, counter down input, load input, and preset value input. And then we go to really important block, which is SR flip-flop. This is a combination of a set and a reset instruction where the dominant signals are dominant signal is reset signal. What does it mean? It means when we press the start and the stop buttons in the same time, it means that the stop button is a dominant signal. For safety issues, it is really important. So in our program, we'll use such an instruction to control the state of the machine. We can control the status of the machine. The status could be in a start mode or in a stop mode. Remember, hit the like button down below the video. Hit the like button down below the video and subscribe to our channel for more automation content. We'll create more videos, more YouTube lives, and many more materials if you want to. But I need your likes to grow our channel and to reach more people in the internet. So it is free. You can hit the like and let's go to the next instruction. Where I come from, we have Africa, Mandla, South Africa. Thanks, South Africa. Welcome you here. So we have flip-flop, and we use that in our program. If we go to the network 3, look at that. I will analyze the logic behind that. So we have the start state of our machine. The machine is in a start state. And when the package goes to the sensor beam, it triggers the input of the timer on delay, and after 200 milliseconds, there is an impulse on the Q output of the timer, and our flip-flop SR is set to true. On the Q output of flip-flop, the true signal appears. So our flip-flop is set on. This flip-flop is connected to the output Q0.0, it means it starts our pusher, our pneumatic cylinder. Okay, but if we reaches the front limit sensor of the pusher, our flip-flop is resetted. It means we have the signal from the front limit switch and it goes to R1 input. It is resetted. Thanks to that, our sequence works fine and all the packages are pushed to the remover. Do you have more questions? We have greetings, Matt. How do you map the factory IO tags to TIA portal? Okay, I will show you how to do that. So if you go to File, Drivers, and here I can map, look at that, I can map all the signals to factory IO, okay? Also, I can map the signals for outputs. So it is really simple option to do that. If we go to configuration, here we have also declare how many inputs we would like to map and outputs. What's more, in TI portal, look at that. We have addresses on the input. I have addresses I0.0 for the first input. For the second input, I have I0.1, etc. If we go to the TI portal, I have some variables and the addresses matches to the factory IO addresses. So it's really simple. I need to just match addresses. If we go to project tree and we go to PLC tags, here I can map all the addresses and all the variables. If we see the stop button, the address matches to the stop button in factory IO. Yeah, the same with the start button, pushers, and so on. Here we have the start button, I0.0. And we have extend variable for Q0.0, the same here. It's really simple. Hello from Uzbekistan. Nice to have you here. Okay. So I think that's all for this simple application. If you have more questions, you can ask below the video. This YouTube live stream will be recorded on our YouTube and you can watch it later. I have something more for you. Maybe I will show you what more you can do in Factory IO. Look at that. Here we have the filling tank. If we do all tags, I can fill here this tank. I can control the process. I have more scenes like even automated warehouse, elevators, conveyors, production lines. All this you can simulate in Factory IO for free, so you can learn for free. If you go to our website, control by .tech. I will leave you a link on the chat. Right now we have a discount price for our course, and we're looking for new PLC programmers that would like to learn on our e-learning platform. Here we have premium Siemens PLC programming ladder logic. If you go to our website, you have only 3 days to make your mind and join our course in a discount price. If you click here, you can watch this video, and my business partner Jacob Bedulski will show you what you will find in that course. Here we have the description, and you will work in PLC simulator and Factor.io, which is virtual factory. Right now, you can buy it in this discount price. Here we have a course outline, and you can also check free lessons, sample lessons, and all the content inside the course. What you will find, you learn about PLC hardware first, then we'll show you how use PLC on electrical schematic. When we go to the basic bit instructions, timers, counters, and we'll go straight to the project. The first project will be the project with conveyor and alarming. You will create an alarm with a timer on delay, timer off delay, and many more. Then you go to counters to count, for example, boxes on the line and create a buffering project. You will buffer containers on the line. Then you go to the pallet sorting line based on product high, and you will sort elements on the line by the color. This is a sorting line with a vision sensor. Also, you learn about operations on integers and real variables. It is really important how PLC operates on variables, how to create mathematical operations in PLC memory. Then you go to the programming regulator for a water tank. Here you will implement PID regulator. Use comparators, and you will use analog values to create such a PID, and to create a control cabinet for this project. Then you will go to the last project, which is programming 2-axis manipulator, and you program all the sequence for that. Okay, so what could be your path in industrial automation in PLC programming? This is your next step in PLC programming. You are here, and I think the best option is to start with our course, PLC Programming in Ladder Logic, which I showed you today how to smoothly start programming from scratch. You can also buy the package with a industrial automation basic, and then you can go to the step number 2, where you learn SCL, text-based language, and communication protocols like Modbus, and also learn about servos drives. Then you can also learn about codesys. So how to start PLC programming without spending a ton of money? If you are starting with automation and programming, you're probably in one of these places. You have finished school and you're looking for the first job. Maybe you have been working for a while and want to work as an automation programmer and have a good salary. Or you get bored with with your previous job and you're looking for challenges. Maybe you're a hobbyist and programming robots and PLCs for you is really nice. So, how to boost your programming skills? Sign up for our premium PLC course, join our Discord channel, learn PLC programming from us, give us your programs for review, and build an amazing project portfolio. Then you can share it on LinkedIn, also with a certificate of completion. We have a PLC programming course for you and over 100 practical lessons. This is the one of the lesson in our course. Look at that. Here we have the conveyor. We create and the simple logic here from the stop button, stop button sensors, and also the selector on the control cabinet. Yeah, and you will use it to create the sample logic. When you go to your homework, for example, this is your challenge, and you will create a conveyor line to buffer containers on the line. Look at that. You have a control cabinet, and you have an entry conveyor, and also alarm and some sensors on the line. You can dock all tags and monitor all the elements on the line. Yeah, and what we are doing here, you can buffer all containers on the line. Then we'll go to the such a project. This is the project for pallet sorting. We have the entry conveyor and we have the left conveyor and the right conveyor. We sort pallets based on the height of the boxes on the line. In the middle of the line, we have the curtain. We measure the height of each box, and based on that information, we send the pallet on the right or on the left. In that case, we need to create a sequence, and usually in industrial automation, we need to create such a sequence on the graph. Look at that. Here we have the entry conveyor. The pallet is waiting for the entry. Then in the chain transfer conveyor, we measure the height and we pick the pallet. Also, we can create for such a project graph set diagram. Graph set diagram is a diagram for creating sequences for the machines. And here we have some steps in such a machine. The first step, awaiting for a pallet, then the 10 step, enter a pallet, and step number 20, move the pallet on the left, or step number 30, move the pallet to the right. Also, in TA portal, you can easily convert ladder logic diagram to FBD diagram, and we show you how to do that in our course. Mathematical operations, here we show how to use them in a PLC memory and do mathematical operations. Then we go to the really nice project, which is sorting elements by the color. And look at that, here in the middle, we have the gate with a vision sensor, and based on the color, we send such an element to the proper sorter. We start the sorter and we push the element to the remover. In that case, the most important is to know how to use vision sensor and how to use instructions to control such a process. So in this project, you need to create a lot of networks and the sequence for each step. Look at that. Here we have the different sequence for sorting conveyor and also a separate sequence for entry conveyor. If you want to be PLC programmer, the most important part is to just know how to create sequences, how to create graph diagrams, and then how to create PLC programs in ladder logic using graph diagrams, sequences. When we go to the project with a liquid tank, and here we create PID algorithm from scratch. This is a process application, and we control the level of the liquid in the tank using PLC simulator and PID regulator. The differences between function block and function and OB block, then we'll show how to use that in your project. The next project is sequence for pusher, but in this part you learn how to create a function block. Function block is a block that can be used multiple times in your project. So you create program only once and you can use it multiple times for the same object. Like in this project, you have 3 pushers or pneumatic cylinders. You create only one program for that, and you can use multiple times. For example, you have 100 pushers. Thanks to that, you can automate your work. It is really important in industrial automation to create such function block diagrams. Look at that. You have 3 pushers and only one function block to control each pusher. This is the view of such a block. Look at that. We create from scratch the block with inputs and outputs. We connect only start button and sensors to the inputs, and we connect outputs coils of the pusher. In the end, you'll create the final project. After that, you'll receive a certificate of completion and you can share such a certificate on LinkedIn. Look at that. This is 2D manipulator for stacking products. We have the entry conveyor, and we grab each element from the entry conveyor, and we stack all the elements in a box. In such a project, we use such elements like arrays, structures, for creating a small database for our application. So this is the final project, the most important. And in such a database, we save the ID of the element, color of the element, and the weight of the element. This is our solution for that. And of course, we need to create a sequence for the whole project. Remember, the PLC is really powerful device, and you can store in the memory a lot of stuff. Okay. Now I will show you how to join the course. If you go to our website and you will click buy the course, here we go to the next website, ladder pack, and you can choose here the single course, or you can choose the bundle. If you want to join 6 courses on industrial automation in a good price, you can choose PLC Bootcamp. And this is all you need to start and land your first job. 6 courses in a one package in this price. You can add it and start learning. Another option is package, Basic of Automation and Siemens PLC Programming. Here we have Ladder Logic Programming Course and Industrial Automation Basic course in a package. In my opinion, the best option is to choose that or that. But if you want to choose only one course, click on Add to Cart and you will go to Stripe. Here you will choose, you can pay in euro or you can choose your local currency to buy it. In the middle, on the bottom, you can also add another course in a discount price. You can add it to your order, but you don't need to do that. You can choose only one course, and on the right, just type your email. You can choose your card. You can pay by PayPal or another popular method for payment solution. Then you can click pay, and you will be added to our e-learning platform. So now you know how to join our course. And I have some sample slides in the end. Maybe you would like to program PLCs and work with projects by yourself. In our course, you will have challenges to solve on your own, but you will receive programming tips how to solve that. You'll be able to use your knowledge in real projects in the future. Maybe you don't have time for training. Don't worry, you have 24/7 access to the training from a computer with internet access. So after purchasing the course, you will get access to our e-learning platform with all the materials. How long does the training take? It takes about 1 to 2 weeks. It depends, but you can also spread your activity. You can do it on your own pace. All the time, we support you on our Discord chat. What's more, we have safe transactions and 40-day money back guarantee. If you say this course is not for me, we'll send you money back. You can use PayPal, Stripe. Okay. I have a question to you. Do you want to sign up for the PLC training on our e-learning platform? More, check out contribite.tech, our website, and see you in the course. Remember, you have only 3 days to get started. I will type here once again contribite.tech. And look at that. Here I have the promotion for the Siemens PLC programming course. I sent you on the chat. And you can join. Today we have only 3 days to get started. You can also find more on our blog. If you go to blog, we have a lot of free tutorials, but in my opinion, the best option is to start with the paid course with a certificate. You can share this certificate on LinkedIn and build your future in industrial automation. Thank you for watching. Now you know how to create a project for pneumatic cylinders, and see you next time. Hit the like button, subscribe for more industrial automation content. See you.